Hello and welcome back, future scientists. I'm Mr. K with Mississippi Public Broadcasting. We're going to continue looking at the science portion of the ACT today and see if we can improve your scores, improve your times, and just make sure you know what's going on when you get to this part of the test. So today I'm talking about generalities of science, and what that means is although the science portion of the ACT a lot of the time can just feel like a graphic literacy test, there is some science that you have to know coming into it and certain things that you can work on to improve your score. So that's what we're going to talk about today. So let's go ahead and get into it. So I wanted to talk about some concepts that are found in all science subjects, okay? So some scientific principles can be found in all four subject areas and in the different passage types. So for science experiments, students should have a basic understanding of experimental design. So you're going to need to know what some of the tools do, what some of the lab equipment does. You're going to need to know about how to talk about procedures in an experimental design process. We need to know what a hypothesis is. Why is a hypothesis so important? We're going to need to be able to identify different variables, so independent, dependent variables, and we're also going to talk about some of the different units of measurements. Some units of measurements you are expected to know walking into the test, and some units of measurements are given to you if they're used on the test. So that's some of the things we're going to talk about today. So first of all, let's talk about what a hypothesis is, why you need to know about it on the science portion of the ACT, and what types of questions you might get about a hypothesis. So a hypothesis is a key component of scientific investigations, offering an initial explanation based on limited evidence. Scientists use reasoning to formulate hypotheses, but remain open to revisiting them after experiments. On the ACT science test, a hypothesis may be explicitly presented or inferred based on the provided information. Students may be asked to identify questions that can be answered using only the passage details. These question types evaluate a student's ability to grasp the motivation of a scientific investigation, relying on the experiment description and results alone. So what's going on here is that if you get a question about a hypothesis on the ACT, there's a couple of different ways this could go. One, they might ask you to infer what the hypothesis was. So they'll give you the experiment, what the results were, and then you're going to have to figure out what question were they trying to answer. Okay, I wouldn't say that that's very common. This is the one that's a lot more common, is sometimes you'll be given explicitly, they'll tell you verbatim what the hypothesis is. And then they might ask you to look at a piece of information and see if that either disproves or strengthens the hypothesis. And you're going to have to be able to tell, would this new piece of information make that hypothesis more a stronger argument or less of a strong argument? Okay, so those are the types of questions you might get about a hypothesis on the science portion of the ACT. Let's talk about variables next. Okay, so three types of variables are involved in scientific investigations. One, independent variable. Okay, these are variables that are manipulated by the experimenter. Its values does not depend on the other variables. Another type of variable is a dependent variable. A dependent variable, it gets its values depend on other variables, typically the independent variable. And then lastly, you can have controlled variables. These remain constant throughout the experiment to ensure consistent conditions. So you've probably heard these a lot in your science classes. They appear on the science portion of the ACT a lot. We're going to need to be able to identify what the independent and what the dependent variables are on some of these questions. I wanted to go through and give you a couple of examples really quickly, just so we can kind of wrap our head around what these three variables are and how they're different from each other. Okay, so first of all, let's talk about, this is an example. Let's say that in an experiment studying the effects of sunlight on plant growth. Okay, so let's say we have an experiment. Our hypothesis is we're trying to figure out the most a plant can grow based off these different amounts of sunlight they're given. So if that was the experiment, these would be the different variables that are a part of it. So the independent variable might be the amount of sunlight or hours per day as this is this is the variable that is controlled by the experimenter. So if I was running this experiment, I could give a plant a lot of sunlight, I could give a plant a little amount of sunlight, but I'm the one manipulating that variable, so it's the independent variable. That's what I'm really trying to figure out. If my goal is to figure out how much a plant can grow based off these different sunlight exposures, then I'm the one manipulating this variable. Some plants, these plants over here get a lot of sunlight, these plants over here don't get any sunlight. I want to see which ones are taller by the end of the experiment. Okay, so the independent variable would be how much sunlight they're getting. The dependent variable might be the plant height or growth rate. This is going to depend on the amount of sunlight received. So from my understanding of how plants work, the plants that get a lot of sunlight would probably grow really tall, and the plants that don't get much sunlight wouldn't grow as tall. So these are the height of the plant, or how much they grow is dependent on the amount of sunlight they're getting. That's why this is called the dependent variable, because it relies on the independent variable. Lots of sunlight, tall plants. Not much sunlight, short plants. So the independent variable is dictating what the dependent variable does. The last type of variable is called a controlled variable. These are, an example for this experiment might be types of plant species or the amount of water given, which would remain constant to ensure consistent conditions across all plants. So if I want to see how sunlight affects plant growth, these would be things that I would keep the same to make sure my data is reliable. I want to make sure they're all getting the same amount of water, because I don't care how much water they're getting, I care about how much sunlight they're getting. So I'm going to give all the plants the same amount of water. If I'm concerned with how much a plant grows given certain amount of sunlight exposure, I would want to make sure that all of the plants are the same species. If this plant grows really fast and this plant doesn't grow very much at all, then my data is not going to be very consistent because I'm using different plant types. So these are different types of variables that are used in experiments and that we need to be able to identify. As far as the ACT science test, these are kind of some questions you might get here. So common questions ask students to identify the independent or dependent variable or to determine a variable's type. Questions on controlled variables are less common. So those are the three types of variables. You will get questions on all of them, but questions about the independent and dependent variable are much more common, and questions about the controlled variable are less common. Okay? Okay, let's talk about units of measurement. Okay? So students do not need to perform complex conversions for the test, but should understand basic unit relationships. Here are a few key prefixes to know. So you're going to want to know a lot of the things on the metric system. So for example, if you see the prefix milli or kilo, you should know what that's indicating. So milli, as in milligrams, indicates a unit that is 1,000 times smaller than the base unit. So 1 milligram is 1/1000th of a gram. Kilo is the opposite. Kilo indicates a unit that is 1,000 times larger than the base unit. So for example, 1 kilogram would represent 1,000 grams. They do expect you to know this on test day. So if you're not very confident with converting on the metric system, practice that. Okay? On the ACT science test, students may be asked to convert between common units, which are generally not defined on the test, as they are expected to be familiar knowledge. So if the ACT decides that these units of measurement are common, they will not describe them or define them in the text. Ones that are more rare, they will tell you what they mean. Okay? Here are some units of measurements that you want to be familiar with. Okay? So as far as length goes, we need to know meters and all the different metric system versions of it. So millimeter, centimeter, meter, and then kilometer. For volume, we want to know about liters. Okay? And there's a couple of different liters, ways to describe volume here. So for example, you can see m squared, that's length in 3 dimensions, you know, height, width, and depth, and that would give you the volume of a space. Okay? Some other measurements that we need to know here are for mass, we want to know about grams. So we want to know about milligrams, kilograms, and grams. And then for density, these are some that you might see. These are milligrams over liters or kilograms over meters squared. And again, that meter squared is a way to talk about the volume of something. Okay, so these are ones that they are expecting you to know. So if you see anything on here that you're not confident with converting, you might want to practice that a little bit because there's a good chance it might pop up on the ACT. Okay, let's talk about math and doing math problems on the ACT, the science section specifically, okay? So although not a math test, the ACT science section includes math as a key part of analyzing scientific data. Here are some clues in the passages that you might get and what they are really telling you what to do. If you see words like per or each, this suggests breaking down a larger group into individual components. So you might be dividing in this situation. Words like all or total imply considering all the components together. So that might be addition. Okay? As far as calculator restrictions go, calculators are not allowed on the science portion of the ACT. So the math operations will be simple and manageable. They know you don't have a calculator. So if you have to do any math, there is going to be math that you can do easily in your head. My suggestion would be just to round. Rounding is okay. If you have a value that's 9.8 and you're trying to multiply or divide it, just change it to 10. That's going to get you close enough. Okay? The answers for these are not going to be so close together that you can't do the math in your head. So it's okay to round. It's okay to do some quick math and to find an answer that's very, very close to the right one. Multiplying 9.8 times 3 is a lot harder than multiplying 10 times 3. Everyone can do that in their head, and that's going to save you some time. So it's okay to kind of round in these scenarios. Okay? So here are some common calculations you might be asked to do. The test may ask for the average values, though they rarely ask for other statistics like mode or median. So you might have to find the average, but you won't have to find the mode or the median. Here are some implied math operations. So students may need to add, subtract, multiply, or divide, and they won't always use those words directly. Instead, terms will imply the operations needed. And I'm going to put some of those words on this next slide, and we're going to talk about, if you see these words, what they're asking you to do. Okay, so let's look at these. Let's look in the top left corner. These are all addition operations. So if you see the word both or combined, together, total, how much, or increased by, the operation you're probably going to need to do is addition because you're putting those informations together to find a total value. Okay, bottom left corner, let's talk about subtraction. If you see the words decreased by, the difference, fewer than, less than, reduced, or how many more than, you're probably going to need to subtract something. Okay, so these are key words. They're telling you what math operation you need to do, and we just need to get familiar with kind of decoding this specialized language. Okay, top right corner for multiplication. The terms that they use on the passage or in the test might be every, factor of, multiplied by, times as great, or product. If you see those words, they're probably asking you to multiply something. And then lastly, division in the bottom right corner. If you see words like half, a fraction of, divided by, ratio of, per, percent, or proportion, those are probably all telling you you're going to need to do some division here. So get used to, if you're struggling with this, I would suggest just doing word problems from a math test. Because a lot of time they use these words here, and that can be some good practice on what operation to do. Some of these operations are fairly straightforward. Some I wanted to point out is difference. This is the word you use. The answer to a subtraction question is known as the difference. Okay? The answer to a multiplication math problem is called the product. Okay? And then so those are just some words we want to get kind of familiar with. If you see these words on the test or the passage, those are the math operations they're really asking you to do. Okay? Y'all, thank you so much for making it here today. Your teacher has some other work for you to do, so make sure to give that your best effort, and I hope everybody has a great day.